From the very first instant, imagine diving into a microscopic world where atoms drift like glowing fireflies, slowly locking together to build something astonishing. A crystal growing one molecule at a time, right before your eyes. At the heart of crystal growth is a repeating pattern, like a perfect three-dimensional wallpaper. Each incoming molecule must land in just the right spot, matching this pattern so precisely that order spreads outward in every direction. Everything begins with nucleation, the tiny first cluster. A few molecules cling together long enough to form a stable seed. If the cluster is too small, it falls apart. If large enough, it becomes the crystal's microscopic birthplace. Once a stable nucleus exists, molecules in the surrounding fluid bump into it from all sides. When they hit at the right angle and speed, they stick, extending flat faces and sharp edges that reveal the crystal's signature shape. Growth is a battle between order and chaos. Heat makes molecules jiggle wildly, trying to shake them loose, while the crystal's pattern tugs them into alignment, turning random motion into a carefully organized solid structure. Different molecules and conditions create radically different crystal shapes: needles, plates, cubes, and stars. Change temperature, concentration, or impurities, and the growing pattern bends, branches, or slows to a delicate crawl. On each growing face, steps and terraces act like tiny landing pads. Molecules slide along the surface until they reach these edges, where it is easier to lock in, causing the crystal to advance layer by layer like microscopic stairs. From gemstones to table salt and even ice, all crystals share this quiet choreography, molecules wandering, joining, and aligning. Understanding this dance lets scientists grow purer crystals for electronics, lasers, and future materials.